Hello, mathematicians. Today we're going to be learning about point-slope form. Before we do so, let's go over the slope formula. So the slope formula is m equals y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. And the m represents the slope, which is rise over run, or our rate of change. And here, y sub 2 minus y sub 1 represents our change in y values, and x sub 2 minus x sub 1 represents our change in x values. So if we're looking to find the rate of change, we're subtracting our two y values and two x values. So the point-slope form, here there's a lot that we're familiar with. So point-slope form is represented by y minus y sub 1 equals m times x minus x sub 1. So here in green we have y sub 1 and x sub 1, which is going to be our given coordinate. So when we're asked to write in point-slope form, we're usually given a coordinate and slope. So the green represents the given coordinate, and m represents our slope. Usually in point-slope form, we're given both of these. And the y here and the x here just represents any other y or x value, so any other coordinate really. So if we have the slope formula here and we have the point-slope form, we could see that they're very, very similar. So if I wanted to move around this formula a little bit, so if I took this formula and I wanted to move around some of our variables, since this is y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1, if I multiply this, these would cancel out. And here I have x sub 2 minus x sub 1 times m, which is very similar to what we have here. So I could rewrite this. Equals y sub 2 minus y sub 1. So we could see that the slope formula and point-slope form is very similar, because if we just rearrange some variables, we end up with the point-slope form from the slope formula and vice versa. So if we're given point-slope form and we're given information such as our slope and our coordinate, all we have to do is substitute the variables accordingly. So since y could represent any y value and any coordinate really, we're just going to rewrite this as y minus, because we're not given a second y value, we're just given one, y minus, and here in our coordinate we have two values, so this is our x sub 1 and y sub 1, since we're only given one coordinate. So if we're going to subtract by y sub 1, we are subtracting by 9, and that equals, and now our slope, m, is 4, so it equals 4, times x, we don't have a second x coordinate, and this x could represent any value, so x minus, and we are given one x coordinate, so minus 3. And that's all we have to do to represent this in point-slope form. So here we have our equation in point-slope form, and from this we know that here's our coordinate, the 9 and the 3. Be mindful that this is y and this is x, so it's 3, 9, and our slope is represented by m, which is 4 in this case, so that would be our slope. So here's another example, and all we're really doing is substituting in what we know. So we only have one y value, so y minus, since we're not given a second, so y minus negative 4, because this is x sub 1 and y sub 1, equals, Now our slope is negative 1/3, so negative 1/3. X minus, our given x value is negative 3, so minus negative 3. And that's it. We could actually rewrite this so it looks a little bit better. And by doing so, we would end up with y plus, because we're distributing the negative here, a negative times a negative is a positive. So y plus 4 is equal to negative 1/3, so negative 1/3, times x plus 3, because a negative times a negative is a positive. Now, be mindful that if we're working our way backwards in point-slope form, it's y minus y sub 1. So if we do see a positive here, it means that our coordinate is actually negative. So if we see a positive here, it means our coordinate is negative. So our coordinate is negative 3, because we see a plus here because it's minus a negative, comma, negative 4, and our slope is negative 1/3. So here I have a line, and we're not given much information, but in order to write our equation in point-slope form, I need a point and I need the slope. So here I have 2 points. I could use either or, it does not matter. So y minus, I'm going to use this point. Doesn't matter which one you use because they're both correct. And so y minus 5, because that's my y value. So this is 2, 5. So y minus 5 equals, and now my slope in this case, rise over run. So my rise is 2, and I go to the right once. So my slope is 2/1, or I could just write it as 2. And so I have x minus, and our x sub 1 is 2, so minus 2. And that's it. Now, if I did want to use the other coordinate, my coordinate here is 1, 3. I could use that one, and so I'd end up with y minus 3 is equal to, my slope is still the same, so that's 2, x minus 1, and that's it. And even though these look like two different equations, they both represent the line. And for point-slope form, it could vary because it depends on which point we're using, but it's the same thing. So these two equations are equivalent because they're part of the same line. Okay, so on to the next one. We're going to do the same thing here. We have 2 coordinates. I might as well just write them out first. So this one here is negative 4, 3. And this one here is negative 8, 4. And again, point-slope form, it does not matter which one you use. So y minus, I'm going to use this one over here. So y minus 4 is equal to, and now we're going to find our slope. So our slope would be, so let me go this way. So we're going down 1, so it's negative 1 over 1, 2, 3, 4. So negative 1 over 4. And our x value that we picked over here is negative 8. So it's going to be x minus negative 8, which is the same thing as x plus 8. And again, if you wanted to rewrite this using the other coordinate, it would simply be y minus 3 is equal to, the slope is still the same, so negative 1/4, And then I have x minus -4, which is the same thing as x plus 4. And that's it for this one. And remember that these two are equivalent. It does not matter which point you pick as long as you pick one point and you don't mix up this y value with a different x value. And so now here I have an equation in point slope form, and what I need to do is I need to graph it. So I know that my slope is 3, and I know that my coordinate in this case, so x minus 2, so it's going to be 2, 4. So I'm going to plot my coordinate first, so 2, 4, and my slope is 3, so I'm going to go up 3 over 1. And so I could plot these points down here. So if we go up 3 over 1, it's the same thing as going down 3 and over 1 to the left, because -3 over -1 is still 3 over 1. So if I just plot these points and then connect my line, I should be good. So we just need a few points. Oops, let me try to make that a little bit straighter. And don't forget to put your arrows at the end to show that this line keeps going to the right and to the left. So here I have another problem, and my slope is -1/2. And my coordinate is, so here I have +5 where it should be -5. So this is the same thing as x minus -5. So my coordinate is actually -5, +1. And so I'll move this over. Actually, I'll just plot it. So -5, +1. And then my slope is -1 over 2. So I'm going to go down 1 over 2, down 1 over 2, down 1 over 2. And 4 points is more than enough. So all I have to do is connect these and try to draw it as straight as possible. And make sure to draw arrows at the end to show that your line keeps on going. And that's it. So that's all you need to know for point slope form.